For the last two examples, we're going to be doing problems that deal with sample means. So we'll be using the other formula, the X bar formula. Rather than read this entire word problem, I'll just jump to what the information we actually need. So this one's talking about auto exhaust emissions, or NOx levels. And for this one, they collected the NOx levels for 40 light-duty engines, all on the same type of engines, right? So they said the average NOx reading, or the mean NOx reading, was 1.2675 with a standard deviation of 0.3332. And we're constructing a 99% confidence interval this time. So we start with our mean, our sample mean. So the sample mean is 1.2675. Then we add or subtract our critical value, so the 2.576. And then we multiply that by the standard deviation, which is 0.3332. And then we divide it by the square root of the sample size. And our sample size for this problem is 40. Once again, this is usually pretty easy to type into a calculator. You're typing it in twice, once where you're doing the minus sign, and then the other time where you add the values. So I'll subtract first 2.576 times 0.3332 divided by the square root of 40. And I get 1.132 approximately. And I'll change that to addition. And we get 1.403 approximately. So that would be our confidence interval. Then there's this follow-up question. So in California, a low emissions vehicle has a NOx level below 0.7. So that's for low emissions. Is there evidence that these light-duty engines could be from low emissions vehicles? Well, in our case, we can say no, because the entire interval is above 0.7. So if you have to be below 0.7 and our entire interval is above, then these are clearly not low emissions vehicles. All right, let's do one more. So on this last example, we've got an example about bunions and finding the average angle. So once again, we're using mean angle of the deformity of some bunions. So I'll skip around so you can read the whole thing yourself if you want. But we've got a random sample of 37 patients. And they found for those 37 patients that the mean angle of deformity was 24.76 with a standard deviation of 6.34. And they want us to do a 90% confidence interval. So let's go ahead and put everything down. So you do your average or your sample mean first, so 24.76. You add or subtract the critical value, which is 1.645. You multiply that by the standard deviation, which is the 6.34. And then you divide that by the square root of the sample size. I should have said this on the previous example, but the biggest reason people mess up these problems is they forget that square root in the denominator. It is very, very common that people will drop that. Okay, this one doesn't have a follow-up question, so we just have to come up with the interval and we're done. So let's get to work. So the first value would be 23.045. So, and then the last one would be 26.475. So once again, this is you're 90% confident that the average angle of deformity is between 23.045 to 26.475.